Hello, in this video I have 6 topics that I am going to try to cover in a short period of time. I wrote them down so I would not forget. The first topic would be talking about installed barrel plugs for power supplies to Arduino Unos. Second, connected power supply wires in a branch configuration for proper connection to the battery terminals. Third, connected the 2 batteries in parallel. Fourth, incorporated a series rocker switch at the primary leads of the Braccio power regulator. Fifth, connected wheel rotation encoders to 2 Arduino Uno boards. And sixth, interface the 2 LCD screens to easily monitor the wheel rotations. Okay, so first, I installed barrel plugs for power supplies to the Arduinos. So now you can see back in there's a barrel plug. Maybe it's not that easy to see, but that's a barrel plug for that Arduino Uno. The Arduino with the motor shield does not require a battery plug. The Braccio motor shield, a Braccio shield already had a barrel plug in the previous video, and these two are new, 2 additional Arduinos with barrel plugs. I used these 2 additional Arduinos because I needed to make sure that one interrupt did not have a higher priority over another interrupt, and that is for the wheel encoders that I'm going to talk about afterwards. Okay, so then I connected the power supply wires in a branch configuration for proper connection to the battery terminals. Okay, so at the battery terminal for the master switches, I have to tighten a nut on a shaft, and there are 3 connectors already in place here. If I were to put 4 or more, that connection would not be very secure. So I branched out a wire with this connection here into 3 branches, which this side has 3 negatives, and this side here has 3 positives, and that powers up the 2 Arduinos and the other Arduino back in here. And next, I connected the 2 batteries in parallel. Okay, so the 2 batteries are now connected in parallel. If you follow this, wire goes up to this terminal, and this wire goes down to here. So when we close the switch, it doesn't come on unless the connection is not complete, unless I close these 2 switches. One side has a negative switch and one side has the positive switch in the same configuration. So this way I can have a common ground if I ever needed to have a common ground to assist with circuit communications with upper battery circuits and lower battery circuits, or if I needed to have the 2 batteries operating in parallel. But I wouldn't risk it because I don't want to take the chance of having too much current. So I just would prefer maybe to, if one battery were low, I can actually just use the top battery instead of the bottom battery, or the bottom battery instead of the top battery, depending on what situation calls for that scenario. And then I connected number 4, incorporated a series rocker switch at the primary leads of the Braccio power regulator. Okay, so here I have a switch, this switch right here, that goes to the primary leads of the voltage regulator for the Arduino board. So that way, while I'm working on JOHNN-E-B, the power does not need to be consumed, and the arm will not be moving if it's not needed. So that helps with controlling for safety and not having the arm operate when I don't need it to operate. That's the same reason I had these rocker switches for the wheels, to shut off the wheels while I upload sketches or codes to the Arduinos. That becomes very helpful to control the power supply to moving parts on the robot. Then number 5, I connected wheel rotation encoders to 2 Arduino Uno boards. So now the adapters for the encoders, the wires come from the motor, and I wired up these, connected these wires to the Arduinos. So the right set of encoder wires are connected to the right Arduino, and the left encoder wires are connected to the left Arduino. The reason that I use 2 separate Arduinos is because I have interrupts for each encoder. Once the wheel starts rotating, it triggers the interrupt, and I did not want to have a higher priority of interrupt for one wheel rotating and while the other wheel was also rotating. So this way there's no priority for any wheel rotating, so each one gets equal priority, so I can keep track of the rotation of the wheels. And I interface 2 LCD screens to easily monitor the wheel rotations. Okay, so I'm going to close the switches, the master switches for the motors and the wheel, the DC motors. And here the LCDs are booting up, and I wrote codes to keep track of the wheel rotation, the pulse durations. So now I'm going to show you that when I move I'm going to push JOHNN-E-B forward, and the numbers should increase because each wheel should move forward. As you can see, this is 77, that's 44. This side moved a little bit more than the other side. I can push this side a little more. No, that's 92 or 105. And if I go pull JOHNN-E-B towards me, that's reversed, and the number should reduce. Now this is -3, -19. So I went this way. So the pulse per revolution is 663 pulse per revolution. So I can keep track of and monitor JOHNN-E-B, the wheel rotations, so that way I can maybe even set up waypoints for JOHNN-E-B to arrive at a certain distance. I can keep track of the odometry, and I don't need to have these serial monitor cables connected to my laptop to see these values. Eventually I will remove these monitor cables, serial monitor cables, once I doing a test in my research. So thank you very much for watching.